Hey folks, welcome back to another lesson, and today we're going to look at Newton's second law. So in particular, we're going to look at what Newton's second law is, so state Newton's second law, and also how to apply Newton's second law for some calculations. So just a wee reminder about what we've done so far. Who wins and which way is the acceleration? So have a wee think, pause the video, and see if you can come up with the answer. So hopefully you've tried it, and the answer, if you are observant, you'll notice there are 40 newtons one way, 40 newtons in the opposite way, but there is also a friction of 6 newtons there. So if we do what we've been doing before, remember that forces in the opposite directions, we subtract them. So 40 minus 40 would mean we would have a net of 0 newtons. However, we also have the friction, and remember, friction always acts against the direction of motion. So if the motion is going this way here towards the left, then the friction must be going the other way. So that means friction is acting this way. So that means we actually have a net unbalanced force of 6 newtons going this way. So the acceleration would also be going this way. So in fact, this person here would be the winner. Okay, so just to summarize that in case you've forgotten it, but the unbalanced force is the sum of the forces acting on an object. Forces in opposite directions we subtract. An unbalanced force equal to 0 newtons is the same as balanced forces, and the acceleration is in the direction of the unbalanced force. So this is what we've done so far, and we're going to build on this by looking at it in terms of Newton's second law. So Newton's second law, I would like to copy this down in your notes because you're going to be using this quite a lot. But F is equal to ma, where force, F is the unbalanced force. It acts in the direction of the acceleration. M is the mass in kilograms. And the triangle for this is that you have F at the top and you have M and A at the bottom. And hopefully you remember how to use this equation triangle to help you to get the right equation, basically. Now, let's look at this Newton's second in a wee bit more detail, because there is a wee bit more than just writing down the equation and plug it in. So the first thing is that F here is the unbalanced force, and we calculate this by taking the sum of the forces if they're all acting in the same direction, or if they're opposite forces, i.e. they're in opposite directions, we then subtract them. So it's worth remembering this. It is part of our routine in that slide I showed you after the starter slide. On the second side of this equation, we've got ma, which means that we can use this equation to calculate acceleration. So to get the acceleration, we'd have to work out the unbalanced force, and assuming we know the mass, then acceleration is equal to F over m. And remember that this acceleration is in the direction of the unbalanced force. So to recap, there's really two parts of this equation here. The first bit is the bit where you have to calculate the unbalanced force. The second bit is that if you know the unbalanced force and the mass, you can then calculate the acceleration. So we're going to be doing this with the next couple of worked examples. So first one here, a car moves with an engine force of 12,000 newtons. There's air resistance of 1,000 newtons. The car has a mass of 250 kilograms. Determine the acceleration of the car. So to do this problem here, what I would really recommend is you draw a diagram with all the forces labelled on it. So this is what I mean. Now, you don't have to draw a fancy car. You can just draw a dot or a wee box. It's just something to represent the car. That's all it is. Okay. Now notice I've written down the mass, which is in kilograms. So I've checked that it's in the right units. The engine force, it doesn't really tell me which way it's going. So I'm just going to assume it's going towards the right, and it's got a force of 12,000 newtons. And then the friction, remember, always goes against the direction of movement. So that's why the arrow is pointing the opposite way. And again, I've written down the force there, which is 1,000 newtons. Now, why draw the diagram? Well, if you draw the diagram, you can see it's very easy, first of all, to see all the information you need. You don't need to read the question again, so it saves you a lot of work. And then hopefully when you see the diagram, it's pretty obvious then that the engine force and friction force are in opposite directions. So what do we do when forces are in opposite directions? We subtract them. So step 1, find the unbalanced force. So we've got 12,000 minus 1,000, which is 11,000 newtons. And then step 2, we write down our equation, F equal to ma. We plug in the values that we've calculated so far, and then we rearrange it for acceleration, and that gives an answer of 44 meters per second per second. So just to summarize that routine, because we're going to use this in the next two examples. First of all, we draw a label diagram, making sure we label the forces in the correct directions and make sure everything has the right units. We then calculate the unbalanced force using our rule that if they're in the opposite directions, we subtract them. We then write down our equation for Newton's second law, we plug in the numbers, and then we do the calculations. Okay, so let's try a second example. Now, if you feel confident, I would recommend you try this yourself. If you're not sure, let's just do this one together. So feel free to pause the video and try it. I'll go over the answer with you on the next slide. So an athlete moves with a muscle force of 3,400 newtons. There's a frictional force of 30 newtons from the wind. She has a mass of 50 kilograms. Calculate the acceleration of the athlete. So first of all, as I said, step 1, we draw a diagram. Now, I've not put the mass of the athlete in here, but you could do, and I would definitely recommend you do that. And then step 1, we work out the unbalanced force. So they're in opposite directions, so we subtract them, and we get the unbalanced force as 3,370 newtons. Step 2, we write down an equation for Newton's second law. We then plug in the numbers, and then step 3, we calculate the acceleration. And remember your units at the end. And that's it. Let's look at another example. Okay, so a rocket has weight of 21,000 newtons. If the mass of the rocket is 10,000 kilograms and the engine produces a thrust of 46,000 newtons, calculate its acceleration. Again, if you feel confident, try this yourself. If not, I'll take you through it. So feel free to pause the video and try this one. We'll look at the answers in the next slide. So first of all, draw your body at your diagram. So you can see there's a thrust force going up the way and there's a weight acting down the way. And then remember step 1, the unbalanced force, which gives us 25,000 newtons. Write down the equation, plug in the numbers, and then that gives the acceleration of 2.5 meters per second per second. So hopefully by this third example, you realize exactly how to do this Newton's second law calculation. There is a bit of a routine to it, and if you get stuck, go over the routine, make sure you understand it, and you should be able to answer all the questions on Newton's second law.